Your online application's starting to fail. It's crawling on the network just as fast as a snail. We need evented programming starting from the top. Better write some code so the world doesn't stop. With the non-blocking model, we will be just fine. Built on Google Chrome's V8 runtime. And all you need to do is write some JavaScript code and use the real-time web with Node.
You're watching Real-Time Web with Node.js, and this is level 3, where we're going to be talking about streams. So in Node, we're building a lot of network applications, and we're sending data back and forth. Some of that data might be big, and we want to be able to start processing that data the moment that it arrives, piece by piece. And we do that using streams. Streams can be readable, writable, or both, and you may not have known it, but you've already been working with streams. If you look back at our example we've been going through, that request is a readable stream, and the response is a writable stream. Now let's get the rest of this code back in here. And if you looked under the covers, if you looked on our client side as to what it's receiving when it receives this data, you would see that it receives first dog is running, and then 5 seconds later, it gets another packet which contains dog is done. Up until now, we've only been sending data back to the response. But how do we read from the request if we send some data into the server? Well, that request is a readable stream which inherits from event emitter. It emits a couple different events, 2 of which are the data event and the end event when it's done transmitting data to the server. Let's write some code together where we print what we receive from the request. So here we create the server, we write the status code, and then we listen for the data event. Whenever a chunk of data comes in, we'll log it to the console. We have to call toString because chunk is a buffer. We could be dealing with binary data here. Then when there's no more data to read on the request, it's going to emit the end event, and we can use that to end the response. With this code, we're printing out whatever data we get from the request, but how might we create an echo server and echo back to the response what we're getting from the request? Well, all we have to do is add 1 line of code here and simply say response write chunk. When all we need to do is read data from a readable stream and write it to a writable stream, there's a shortcut in Node that makes this easier. We can simply call request.pipe response. So basically read stream, pipe, write stream. So if we replace our code with pipe and run our server, we can then issue a request with some data, and that's going to get echoed back out to us. Now, if you're familiar with the Unix command line, you might have heard of pipe. For example, maybe you cat a file and pipe that to the grep command to find a specific word. This is the same sort of technique where you're piping a read stream to a write stream. Let's go over another example of streaming. This time, let's read a file from our hard drive and write a file back. So in this case, we require the file system module. We call the createReadStream function, passing in the file we want to read. That returns us a read stream, obviously. And then we're going to create a new write stream for the file we want to write to, which returns a write stream, obviously. All we have to do to read from one and write to the other is simply do file pipe new file. That's all there is to it. Now let's combine both of these examples where we're going to connect to the server, we're going to send the server a file, and we want to write that to disk. What would that look like? Let's include the HTTP module. We're going to create our server. We already have our new file. We're simply going to take the request and pipe that to the new file. We also need to listen for the end event on the request so we know when to end the response. And when we end the response, we can also send in a string that we want to send back to the client. Now, if we run the server and we use curl to initiate a file upload, it'll upload the file and print out uploaded on the client side. Now let's take a moment to reflect upon what's really going on here, because it is kind of amazing. We're streaming pieces of the file from the client to the server, and then the server is streaming that to the hard drive. At no point in time does the server ever have the whole file. It's all streaming. And what that means, because we're using Node, is that it's also non-blocking. So if we take a look back at the timeline, if we send in 2 files at the same time into the server, they're going to be uploading and streaming in parallel. However, because we're streaming like this, piece by piece, it could introduce another problem, which looks something like this, where we're reading files from the client faster than we can write them to disk, and pieces of the file might get built up in memory and fill up our memory, which is bad. Pipe takes care of this for us, actually. It will properly pause the read stream so the write stream can catch up. However, it's important that you know what's going on under the covers. In order to do that, I've got a metaphor for you. This is our milk jug. We poked a hole in the bottom of our milk jug and we're going to start pouring milk into it. We start pouring milk into it. As you can see, it drains out the bottom and it starts filling up and filling up and filling up and filling up. So here, the milk that we're pouring in, that's our read stream, and the milk that's getting poured out is our write stream, and we're reading more than we're writing. So we need a way here to sort of pause that milk stream when our jug is too full, and then once the milk jug is drained, we need a way to then resume the milk stream. Okay. Now, let's figure out how we can do this with some Node code. So how might we pause when the write stream is full? Well, if we're reading the data chunk by chunk, when we call write on the write stream, write is going to return false if our kernel buffer is full. We can then check that, and if the buffer is not good, let's go ahead and pause the read stream. Then we need to know when we can resume when we're ready to write again. We do that by listening for the drain event, and the drain event means we're ready to write again so we can resume the read stream. And as we mentioned, all of this sort of logic is encapsulated in that pipe command. So if you're using pipe, you don't have to worry about back pressure. One of the reasons Ryan Dahl created Node was to deal with file uploads. If you're familiar with file uploads in web applications, you know all of the drama that goes along with doing it well. Sometimes file uploads can lock your server, they can lock the world, and it's hard to get file progress as you upload, but Node actually makes this easy to do. So let's go ahead and try to implement our own file uploader with some progress. Once we complete the file upload code, we're going to want to be able to issue a request and send in a file, either from curl or from the browser, and get back some progress as it gets uploaded. We're going to need 2 different modules to write this, the HTTP server module and the file system module. We might want to go ahead and jump into the documentation and take a look at these 2 modules. One thing you might notice when you're going through the Node documentation, because Node hasn't hit 1.0 yet, different pieces of the code, different modules have different stability levels. So you can see how often they might change. You might want to keep an eye on that when you're coding Node. To create this, we're going to start from our file upload code, which we already created. First, we're going to add some variables. We need to store the content length, the size of the file, inside file bytes. We're also going to declare a variable to keep track of how many bytes we've uploaded so far. Then we're going to listen to that data event, which gets called every time we receive a new chunk from the request. We're going to increase the number of uploaded bytes. We're going to get the length of the chunk and add that to the uploaded bytes. We're going to calculate the total progress by dividing uploaded bytes divided by total file bytes times 100. And we're simply going to write the progress back to the response. That's all there is to it. So let's jump into our terminal and run the code. So here we're running the Node server. Then if we go to upload the file, we can see that it gives us back progress. And we're complete. Very cool. Well, that about sums it up for this level on streaming. It's time for you to get into the challenges, and Eric Allam will see you in level 4.